Well, I'm going to be talking to you a little bit more, I think, about water quantity than quality this morning. And then towards the end, we'll kind of see how that wraps back into the water quality issues that we see on the coast. So I'm the research director of the research program at Corkscrew Swamp Sanctuary. For those of you that may not be familiar, Corkscrew Swamp Sanctuary is a 13,000 acre national Audubon sanctuary located basically due east of the Bonita Springs area in Collier County. The sanctuary was established in 1954, and the reason it was established was to protect the wood stork colony that had been nesting there for decades prior. Audubon has had a presence in that wood stork colony since the early 1900s, when an Audubon warden lived on the site among the colony to try to protect it from plume hunters. The sanctuary was established during the logging days of the Big Cypress, when logging was threatening the trees within which the wood storks nest. And so Audubon helped to purchase the land to set this sanctuary aside for the sake of protecting both the trees, the old growth bald cypress forest, which is now the largest remaining intact old growth bald cypress forest, and the wood storks that nest within those trees every year. So following the establishment of Corkscrew Swamp Sanctuary, Audubon staff started recording the annual nesting of wood storks at the Corkscrew colony. Back in the 1960s, the Corkscrew colony produced about a third of the whole North American or US population of wood storks. And you can see pretty much as soon as we started recording wood stork numbers, we began to see a decline. You can see the wood stork, these are number of pairs of wood storks or number of nests each year, and you can see this decline into recent days. And I talked about how there was an Audubon warden that lived within that colony. Well, there was a famous ornithologist named T. Gilbert Pearson that visited that warden in around 1910, and he talked about there being over 100,000 wood storks in that wood stork colony. So assuming that that's 100,000 birds, total, we don't know. He was an ornithologist. Estimating things like that was something that he wasn't a novice at. Assume that's total birds, including chicks. Maybe there was 5 wood storks per nest. That's still 20,000 nests back during that time. So even by the time the sanctuary was established, the highest number of nests we recorded was about 6,000 nests per year. So this colony has declined. We also know from research that's been done throughout the Everglades that the wood stork is an indicator of ecosystem health in the Everglades. So watching this wood stork population is really important for understanding what's going on within the ecosystem that this species depends on. So in order to try to start understanding what was happening to our wood stork population, several years ago we started looking at hydrology, knowing that is really the foundation of what drives wetlands in Florida. And so we have, in addition to the wood stork data that were being collected daily, or being collected annually at Corkscrew since the sanctuary was established, we had water level data and rainfall data that were collected daily since the sanctuary was established. So these data go back to the late 1950s. And if you think about what Naples and what this area looked like in the 1950s, this was before we had much here, inland Collier County. I think the city of, Collier County, Naples area got its first hospital in the 1950s. They got their first bank in the 1950s. So this was during a time that this region was really underdeveloped. So we have a data set that tells the story of how this wetland was functioning, or what the water levels looked like prior to all of that development. And this is what we found. This is looking at kind of a typical year in the swamp, and I'm going to go through decade by decade here. So what you see along the x-axis here at the bottom is time from June 1st to May 31st. So that's kind of our hydrologic year. That's our water year, starting with our wet season and hurricane season and going through the dry season. On the y-axis, this is water depth at a staff gauge that we have along the boardwalk at Corkscrew in the Lettuce Lake. So it's in one of our deeper spots that was relatively easy to get to, A staff gauge is essentially a big ruler, so we would just have volunteers and staff that went out and measured depth there every day, and we have a 60-year data set that tells us the story. So looking at this graph, you can see, as you would imagine, the wet season begins, water levels go up, we reach our peak water level for the year in about October, and then the swamp slowly begins drying down, and we have a long, slow recession that brings us into and through the dry season. And water level just continues to go down until the summer rains begin again. And that's that flux of wet and dry that we see each year here. So this is what the hydrology of Corkscrew Swamp Sanctuary looked like in the 1960s. And each data point is basically an average of the 10 years within this decade. So this is just giving you a snapshot of what typically that decade looked like. This is what the hydrology looked like in the 70s, the 80s, the 90s, which what you can tell was that the dry season was a little bit wetter in the 90s. And then finally in the 2000s, we see something drastically changed. And then the 2010s, we see it even more pronounced. And what we're seeing happening is we're still reaching about the same peak in the wet season. We're still filling the swamp up to the same level, but once the dry season hits, our water levels are dropping much faster than they ever did historically. And that means that we're drying down in the dry season for a much longer period than we did historically. I put this back up just for the contrast, just to see the shape of what these curves look like in the 1960s versus the 2010s. You see the same peak in the wet season. We're still filling up to that same level. Think of it as kind of filling a bowl or filling a swimming pool, and then we're just drying down quickly in the dry season in a way that we didn't historically. So we looked at the hydro period and what this means for different habitats within the sanctuary. What does this mean for our marshes? What does this mean for our cypress forest? And we looked at the hydro period, the number of days per year that each of those habitats has standing water. And what we found was that has decreased on an order of 20 to 30%. So the number of days per year that those habitats are holding water is 20 to 30% shorter in the recent decade than it was in the 1960s. And this is a paper that we published this fall that you could look up here. So what does that really mean? It means that if you went out to the lettuce lakes off the boardwalk at Corkscrew Swamp in the 1960s, you would have seen the lettuce lakes dry down about once every 5 years. And in recent decades, we're seeing the lettuce lakes dry down about 4 out of every 5 years. And when it does dry down, it's drying down for about 40% longer than it ever did. And this is something that was kind of happening under the radar. Our hydrology changes so much year to year, this swing between the wet season and the dry season, that subtle year-to-year differences are harder to see. And every year when we have this wet season followed by a dry season, and then we might have a weird drought year in the middle, or we have a really wet hurricane year, it kind of resets our clock, and I think makes us miss some of these bigger picture changes that are happening because we live in such a dynamic system. So all of this change was happening when we were seemingly unaware of this dramatic change. Until 60 years later, we look back at the data, and luckily we had those long-term data to be able to look back at, which is, I think, a unique part of this story. A lot of our natural areas we're not monitoring, and so we're not able to detect changes like this. But we had the luxury of this 60-year data set that we could look back on and see that while we have these changes year to year fluctuating, if you step back and look at the big picture, we're seeing a long-term change. So what is that? How does that line back up with what we've seen with our wood storks? Well, we looked at how that hydrology changes year to year in this analysis. And we looked at, well, we know that sometime in recent decades, wood storks stopped nesting as frequently. We started having more years that the storks just didn't nest at Corkscrew. Sometimes they would come to Corkscrew, sometimes they would nest, and a few of them would begin nesting and then they would leave. But there were distinct years that so we looked at it on a really coarse level of whether they nested or whether they didn't nest. And we overlaid that with when we saw changes in hydrology. So this is a little bit confusing, but the main point here is that these vertical lines represent years when there was a change in hydrology. We saw a little bit shorter hydro period in this year here, this red dot, which corresponded with a year that wood storks didn't nest. We saw another kind of small shift in this period here, which again corresponded with this red dot, which is a year that wood storks didn't nest. And then we saw things really kind of go off the rails here in 2016, and we saw hydrology, the slope of this line, get steeper and stay steeper. And that began, coincidentally or not, with a period of time that wood storks didn't nest very frequently at all. So while we're not able to show cause and effect through this, if we overlay these two data sets, it certainly suggests that these changes we're seeing in the hydrology and the changes we're seeing in the wood stork population are related in some way. So I kind of present Corkscrew here as a little bit of a canary in the coal mine. Corkscrew is an ecosystem, a natural ecosystem in inland Collier County that has this long legacy of ecological data that we're able to tell the story of what happens over time to these inland wetlands. And I think that while we're talking about the sanctuary, I think Corkscrew actually provides a little bit of a cautionary tale for what we're seeing in inland wetlands, perhaps throughout our region, that we're not able to measure, we're not able to describe because we don't have the same long-term data there. So here's the sanctuary. I should have put this up sooner, but here's the sanctuary, and you can see it within the greater context of Southwest Florida. You can see it here at the heart of the 60,000 acre CREW, the Corkscrew Regional Ecosystem Watershed. And you can see that Corkscrew is in a part of our region where it's getting slowly infringed upon by changes in land use adjacent to the sanctuary. So it kind of begs the question, where is this water? Where's our water going? What changes are happening that could be causing this? The first is water management. As more people are moving into the region, we have more homes and businesses that we need to protect, more roads that need to have water routed around them. We're putting more water management structures in. So this could be a part of what we're seeing. We could be losing water through the south end of the system in the wet season when we're trying to get water off the landscape. That's not allowing us to hold water into the dry season. Another possible factor is agriculture. The north end of the sanctuary is that Corkscrew Road corridor where there's tons of agriculture. And so, that's moved in recent decades. And that agriculture, we know, is using a lot of water during the dry season, which is when we're losing our water. They're using a lot of water during a time of year that there's not a lot of water to be found. Another obvious potential cause, is the increase in residential development. Water use, both drinking water, landscaping, other water use that the increased human population is bringing into our system. And then finally, increased evapotranspiration, which is something that we're seeing not only in Southwest Florida, but throughout, I'd say, a lot of areas of peninsular Florida. And that's basically a change in the vegetation due to less prescribed fire and due to overdraining the landscape. So we have wetlands that are dominated by grasses and sedges and other herbaceous vegetation that begin to get invaded by native plants in a lot of cases that are woodier. And those woodier plants have a higher evapotranspiration rate, and they also have deeper roots that allow them to access water down, within the ground longer throughout the year. Another kind of thing with this increase in ET is something that Serge, I think, touched on earlier, which is this pond, the presence of these ponds throughout the system, which are increasing evapotranspiration in our system. So between changes in vegetation and other changes in the landscape, increased evapotranspiration could be another factor that is, creating this change. And we're currently in the process of trying to start up a hydrologic modeling project to really get at trying to rank out these factors and see which one could be the biggest cause in what we're seeing at Corkscrew. But perhaps more importantly, what are the implications for this? Well, certainly impacts for wildlife. Fish live within that water that's rising and falling, and those fish are the base of the aquatic food web, feeding things like alligators, wading birds, otters. They're really the foundation for any of that wildlife population that is in that aquatic interface there. Certainly there's also impacts for plants. And that's something that was touched upon this summer during a lot of the talk about the ghost orchid at Corkscrew, and it was actually a story that was also picked up this fall by National Geographic. When we lose standing water under the canopy in the cypress forest, we're changing the microclimate under the canopy. That standing water is buffering the temperature and buffering the humidity, and all of those epiphytic plants that live under the canopy are depending on those environmental conditions. So when we lose that water, especially in the dry season, which is some of our colder months, we're losing that protection for those plants underneath the canopy. And that's just one example of how that can have an impact. Another, factor is our increased wildfire risk, and not even just our increased wildfire risk, but the increased risk of catastrophic wildfire. We're over-drying a landscape that is dependent on fire. We're in, essentially the lightning capital of the world. We're in one of the most pyrogenic or pyro-dependent ecosystems in the world. And by having the system that's not only under-dried or over-dried, but under-burned, not maintained as well, we're setting ourselves up for a big fire issue. And that's a fire issue that could threaten places like Corkscrew Swamp. It's also impacting our freshwater storage, our water supply. It's decreasing the amount of water that we have available to push back the saltwater intrusion that we know is always a factor on the coast. And then finally, reduced freshwater filtration. If that water doesn't have time to sit on the landscape in those wetlands, having time to percolate down into the aquifer, to recharge the aquifer, and to pass through wetlands that provide that natural filtration, we're losing that and sending that water right to the coast, which we know is a source of a lot of our coastal issues. And finally, the freshwater supply, moving towards the coast is also affecting salinity on the coast. It's providing that salinity buffer that is keeping those estuaries at the, lowering the salinity in a way that is, ideal for the estuarine environment. So how big is this problem? Is this just a Corkscrew problem? This is a study that we did a few years ago, just looking at short hydroperiod wetlands. So these are just wetlands that a lot of us overlook even as wetlands. They only hold water a couple months out of the year. They're dry most of the year, so a lot of times we drive right past them or walk right through them and don't even recognize them as wetlands. This is in this map, we've highlighted the short hydroperiod wetlands in pink prior to development. And this is in 2004, so this is even, 15 years old. It's not updated. So we've lost a ton of these wetlands, and we're continuing to lose more. And as Bill just pointed out, with the changes in wetland regulation, we're going to be losing even more of them. So finally, just a few conclusions. Southwest Florida doesn't have the same hard barrier for development as we have on the East Coast. Here's a picture of the East Coast. The pictures are a little bit hard to see, but you can see that the levees that run along the water conservation areas, this is a hard barrier for development that you see over there. And we don't have that luxury in Southwest Florida. We have a mosaic environment that's allowing development. These are on the same scale. This development in Southwest Florida is pushing farther and farther in because we don't have that same barrier. Because of that mosaic characteristic of Western Everglades, we are putting wetlands immediately adjacent in some cases to uplands. So we're allowing development on land that's immediately adjacent to wetlands, which is really degrading the quality of those wetlands. Widespread wetland loss in our region is making it much more important for us to protect our remaining wetlands. The remaining wetlands that we have right now need further protection because they're the only thing we have left to fulfill these important ecosystem services. And then finally, I think we really need to broaden our conversations about the link between freshwater ecosystems and the coast. I think in general in Southwest Florida, we treat those as very different issues. And I think we really need to focus more on the interdependency of the coasts and our inland freshwaters. And that's all I got. Thank you so much.